All right, the last part of section 6.7 and the main purpose of this particular section is to graph polynomials. I'm going to do one example for you that will illustrate the steps. Please write the steps down in this example and follow these steps for any polynomial that you need to graph by hand. Step one, first of all, find all possible solutions. Now remember, that involves the factors of the constant term and the factors of the lead coefficient. Well, very simple. The factors of the constant term are going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. The factors of the lead coefficient are just 1. So therefore, all possible solutions are really going to be what I just circled in blue. Now, step 2. Take your calculator out and find one of those solutions and prove it to yourself. Well, if I look at my calculator, I find out that it looks like -1 is one of the solutions. So we're going to test that. I'm going to put in my coefficients and do synthetic division here. Draw my line, and then we're going to do this in black. Bring down the 1. -1 times 1 is -1. Add them, you get 2. -1 times 2 is -2. Add them, you get -8. -1 times -8 is 8. And hey, I get a remainder of 0. Beautiful. So therefore, since it looks like -1 is one of the solutions, then it must have a factor of x plus 1. And then the other factors are what I circled, which is 1 power less, x squared plus 2x minus 8. So there's my factors. I'm going to go forward a slide to the next step where I list the factors, and we're going to write those down, which is x plus 1, and I believe it was x squared plus 2x minus 8. Now, factor completely. I got to look at this part, and I know that's factorable. I can tell that right now. So therefore, I get my factors are x plus 1, x plus 4, and x minus 2. So this one worked out really nicely since I've got my complete factors. So step 4 then is to list the solutions. Well, we know this factor gives you a solution of -1. This factor gives you a solution of -4. And that factor gives you a solution of 2. So I'm going to go back a slide to our graph, and I'm going to plot those points. Looked like -4 was the first solution. Okay, so put a dot there. -1 was the second solution, which is right there. And it looked like +2 was the third solution. So I got 3 red dots. All right, so we know the graph has to go through those 3 points. But what does it look like? We want an accurate representation of the graph. So, step 5. If you need to pause the video, go ahead and do this. But we need to find the values for one point that are in between each of the zeros. And then we're going to plot them. All right, well, I'm going to go back. I need to find the value of a point in between each of those zeros. So for instance, I'm going to pick -3, for instance. Oops. I want to find out, I can't erase that, but I want to find out at -3 what the value of the function is. That's in between the zeros -4 and -1. And I'm also going to try 1 and see what the values are. So I'm going to go back here, and I'm going to go, let's take our function f and find the value at -3, and let's take the function f and find the value at +1. So if I go back to our function and I plug -3 in for all the x's, I believe that if you do this on your calculator, you will find out that the answer is, when x is -3, the answer, the function, or the value of the function is 10. So -3, 10 is another point that should be on my graph. Negative 3, oh, we're way up here. Negative 310 is on my graph. Now let's try this again. Let's try the point when x is 1. So I'm going to go back to my function. I'm going to plug 1 in for all those x's. And I believe if you do that, you get an answer of negative 10 when you put 1 in there. And so 1, negative 10 will be another point on my graph. 1, negative 10. Oh, oops. That's going to be way, way down here. 1, negative 10. Way down there. Okay. So at this point, we now have a good idea what this graph is going to look like. The last step is to use what we talked about in the last video to determine the end behavior of the graph and then use that to draw it. Well, if you remember, the end behavior is determined by the lead coefficient and by, that's a terrible T, just terrible. The lead coefficient and by the degree of the polynomial. The whiteboard here is a little off, so it's real tough to write accurately. All right, so let's go back. Our lead coefficient is a positive 1, and our degree is 3, which is odd. So our lead coefficient is positive, and we have odd degree. Now, if you check your notes or go back to when you have an odd degree and positive, this is a down and up situation. The graph starts down and finishes up. So when I go back to my graph, I know it's got to go through negative 4, so somehow it's got to start down here and go through negative 4 all the way up to the 10 mark, back down through negative 1, down to negative 10, and it's going to finish up like this. And there is your graph, as accurately as we can draw, of this particular polynomial. And so therefore, you're going to use all the information that you've learned about polynomials. The zeros, which are these, the end behavior, which is down and up, to help you sketch these graphs. If you have further questions, please ask during class, but that concludes this video.